Hello everyone, welcome you all back to my YouTube channel Study with Tej. I am Dr. Tejashwini N, Associate Professor. Today we shall deal with the services that has been provided by data link layer. So they are called as data link control services. Amongst them we'll be discussing about framing, flow control and error control. In framing we should also discuss about how stuffing has been done, byte stuffing and bit stuffing. So coming to framing, okay, what are the functions that has been provided by data link control layer are framing, flow control, and error control. These are the basic or three operation functions that has been provided by data link layer. So what is framing? Framing is basically done in data link layer. This will separate a message from one source to destination by adding the sender and the destination address. Here destination address is required to know where the packet has to go, and the sender address is required to know where the acknowledgement has to be sent. Here we can, the whole message can be packed into one frame. That can be done, but it is not done. Why? Because the reason is, if the frame is too large, then flow control and error control becomes very inefficient. It becomes tough. Suppose if the message that is being carried is too large, then even a single bit error would want us to retransmit the whole frame. Instead, if the message has been divided into smaller frames, a single bit error will only affect that small frame. So we have to just to retransmit the small frame. That's the reason the whole message has been divided into smaller frames than the larger frames. So once that is the case, then frame size. Frame size can be of two things. One is fixed size and another one is variable size. Once it is fixed size, that itself will say where the frame will start and where the frame will end. So the size itself will act as a delimiter. So we need not define any boundaries for the frames. Example is ATM van, which will use fixed size frames called as cells. Variable size here, we do not know, the size is not fixed. That's the reason we have to tell where the frame starts and where the frame ends. So beginning and end of the frame has to be marked. So for that there are two approaches. One is character oriented framing and bit oriented framing. What is character oriented framing? If you can see here in this frame, the data whatever is there, that is of 8-bit characters from the ASCII. Okay, with that we have header, trailer, and two flags, one to mark the beginning of the frame and another to mark the end of the frame. So what does the header contains? It contains source and destination address, also the control information. But whereas the trailer contains the error detection redundant bits, then this flag, usually what we are using, that is composed of protocol dependent special character or signal. These are used to mark the start or end of the frame. So this will separate one frame from another. So here, if this data, whatever we wanted to pass, in the previous frame I said the data, this data, whatever we wanted to pass, what if in case this data contains a flag? Then obviously receiver might get confused that that flag is end of the frame or beginning of the frame. Such confusions are possible. So to avoid that, the solution found was byte stuffing. So here one special byte called escape is being used. That is, if you find a flag in data, we are just stuffing escape byte before the flag. It simply says after this escape, whatever the next byte is, it is not the flag, instead it is the data. Similarly, if escape byte is also a part of data like this, here again we are adding one more escape to tell this escape is not the special bit pattern, instead it is a part of data. While unstuffing will come across this escape byte, then we remove this and we consider this as in regular data and not the flag. Similarly here also we remove this and next is not taken as a special bit pattern, instead it is taken as part of data only, and unstuffed just looks like whatever we had sent. Okay, so this is how byte stuffing shall work. One more approach is bit stuffing, wherein here it if it is bit oriented framing, then the data section of the frame contains a sequence of bits which is interpreted by the upper layer as either text, graphic, audio, video, and so on. So most of the protocol use a special bit pattern flag called one followed by zero followed by six ones, and again a zero. That's this is a 8 bit, that is 1 byte. Zero followed by six ones and one more zero. This is a special 8 bit pattern that is used as flag. So this will mark the start and end of the frame. But what in case if this pattern again occur in the data? So we'll have to again mark that. Should not be confused as the flag, correct? So that's the reason we use bit stuffing. This process is adding one extra zero whenever you find five consecutive ones. You'll understand that better here, so that this bit stuffing is done so that the receiver will not get confused with what is the data and what is the special bit pattern, that is flag. So if you can see the data whatever we have, it has certain pattern, like we are not supposed to use. So then we are just stuffing after five ones, we are just stuffing the zero. Likewise again after five ones we are stuffing zero. Likewise it has been stuffed at the receiver end. Once it has been received, immediately after five, whatever the zero is there, it is taken out. Next, whatever it is, if it is zero or whatever it is, after five ones, whatever the zero is being taken out and the rest is taken as the data. Likewise even this zero is being removed and unstuffed. Bit pattern looks like this. So this is how bit stuffing will work. Next, coming to flow control. So we learnt about framing. Now it is flow control. So when two entities are there and one entity is producing the items and another one is receiving or consuming it, the balance between production and the consumption rate should be same. At the same rate it has to do it. If in case the items produced are too faster and the consumer is not able to consume, then the consumer will be overwhelmed and it might discard some items, or the packets or streams might get lost. So to overcome that, one solution is here at the data link layer, the producer, here the sending node, is trying to push the frame towards the data link layer at the receiving end. Okay, once if the receiving node, it cannot process the delivered data to at the same rate where it is been receiving to the network layer, the upper layer. When it can't do it, then it says no, I am not able to work at your speed. Then it will send a feedback or a flow control message to the sending node telling to stop or slow down the production of frames. Okay, don't push the frames, slow down or stop. So once this message is got here, the sending node shall either stop or slow down the pushing of frames. So this is how flow control has been achieved. So one of the solution for that is using buffer. So using buffer at both the sender end and the receiver end is very important. So buffer is nothing but a set of memory locations that can be used to hold the packets at both the end, sender and the receiver. So one buffer at the sender end and one another buffer at the receiving end will do the job. When the buffer of the receiving end is full, then it informs the sender telling that you will have to stop pushing the frames. Don't send more frames because I'm already overwhelmed. So there's no place to hold it. So this is how the flow control is being done in data link layer. Then the last one is error control. Basically, we are using CRC, which I've already discussed in the previous videos. Cyclic redundancy check is again used here. Two things might happen. That is two methods. One is first, when the frame is been, if in case the frame is corrupted, then it will be discarded as it was mentioned in CRC. If it is not corrupted, it is accepted and it has been delivered to the network layer. The second method is if it is corrupted, it is discarded. Fine, that is okay. But if it is not corrupted, an acknowledgement is sent to the sender to tell the message has been received uncorrupted. It is safe and sound. We have received it, no problem at all. So that is how error control has been done. Combination of flow and error control can also be done. It can be combined in the situation where acknowledgement is sent for flow control and can also be used for error control to tell the sender the packet that has arrived is uncorrupted. And lack of such acknowledgement means that there is a problem in the send frame, and this frame that carries an acknowledgement is usually called as ACK, so that we can distinguish from the data frame. Next is two types of protocols, connectionless and connection oriented. In connectionless protocol, this also I have discussed earlier. The frames are sent from one node to the next node without any relationship between the frames. Each frame is independent to travel. It means that there is no connection between frames. The frames are not even numbered and there is no sense of ordering as well. But whereas in connection oriented protocol, we have to do three things. That is, logical connection should be first established between two nodes. Then all the frames that are somehow related to each other are transmitted. That is called as transfer phase. And the last phase is to tear down that particular logical connection that was established once the data transfer has been completed. So this is all about the services that has been provided by data link layer. Thanks for watching.